So Simone's talking about a Poisson distribution. The thing is, I don't actually know what the mean is, so I'm going to have to figure out what that is. And to do that, I'm going to go back to the original table. Say I've got one square with no oak trees in. I've got 4 squares with 1. I've got 21 with 2. I've got 23 with 3. I've got 13 with 4. 11 with 5. And 7 with 6. That gives a total number of oak trees of 264, and there were 80 different squares, weren't there? So if we divide that by 80, gives us 3.3 as the average per square. We've had to work that out ourselves. So we're going to say that X is a Poisson with a mean of 3.3, fits the data, is a good fit. And H1 is it's not a good fit. Now I've got that 3.3. That's going to be helpful because I think I'm now going to go to my distributions menu and we're going to figure out what the missing ones are. Poisson equal to and let's check the 2 first of all. So they think this should be 16.07. Let's check that. So I've put a 3.3 in there. No, that doesn't work. Oh yes, because I still need to times it, don't I? So 0.2008 variables, statistics, result, distributions, P. And I need to times that by 80. So hopefully that is, yeah, look, that is 16.07. So it does seem to be right. So let's go back and do that again. Distribution menu, Poisson. This time I wanted to go for 3. And so that is 2209. I'm going to write that one down. So 0.2209 times by 80. And the other one I've got to do is for 5, isn't it? And that's 0.1202 times by 80. So menu 1, variable statistics, result, distribution, P, times by 80. So that one there gives us 9.62. And this, what the other one here, I'm just going to type that one in now. That one there gives us 17.67. So they're my values for S and for T. Let's put those in the table there, 17.67 and 9.62. So my next job is I'm going to put all of that data into my calculator to try and do the hypothesis test. Let's pause while I do that. So I've put that data in. So we're going a test, a chi-squared test, a goodness of fit test. Now this time the degrees of freedom, so it's 1, 2, 3, 4, 5, 6. 6 take away 1 and take away the 1 from the estimating there. So this time it's 4. Why was it 3 last time? Oh, it's because we merged those together last time, didn't we? You didn't need to do that this time. So we've got that 4. So we're getting a chi-squared value of 9. Okay, so I'm making some errors here, I think. I'm going to do, we're doing a 5% test with 4 degrees of freedom. Yeah. So the critical value here is 9.4877. And I think they're actually telling us that the test statistic is 8.749. So that tells us that this is less than the critical value, therefore do not reject H0. Evidence suggests Poisson is okay. Simone's model. Suitable. Now the only worry I've got is that I didn't actually need to put it in the table, did I? I think, right, so let's just check. Find the values of S and the values of T. We've done that for part C. Write down the hypothesis test. The hypothesis test here, Poisson is a good model. Actually, I mean, that should really be Poisson-Lander. Poisson is not a good model. Write that clearer when you do it. The test, complete the test. Critical value, degrees of freedom's 4. Critical value is that, not significant. Explain cultivated or wild. So part F. Oh, there's 2 marks for this. Well, cultivated was the binomial. So the Poisson is more likely than binomial. Therefore, more likely to be random, to have grown randomly. So therefore, wild. Is that it? Is that? Struggling to see why that's worth 2 marks, but I'm going to stop there.